So our next talk is by Shawn Clonts on the texture modification of additively manufactured components of Lunar applications. Shawn, are you ready?
Yeah.
Okay.
Awesome. Thank you, Jorge. Can we go to the next slide, please? Hi, so I am a master's student at Arizona State University working on a master's in manufacturing engineering. This is kind of a thesis project that my professor and I have worked up with some folks at NASA. So we have 10 months to work on this project. And I come from a background, the research group I'm with as well, of additive manufacturing, and we're gaining experience with the aerospace field. We want to investigate how additively manufactured textures will affect lunar dust erosion and adhesion. And this is kind of our intended workflow for the project. We haven't done a ton at this point, but we want to design these different types of structures using a topology platform, definitely leaning on some biomimicry, and manufacture these specimens, some test specimens with an SLA printer. Then we want to characterize this using a blue light scanner and kind of see what the resultant texture is of both the designed and process-based texture combined together. What do we end up with? And then we want to test for erosion and adhesion. And our idea for the erosion test is kind of use a modified sandblaster, vary the impact angles, and using a suitable simulant. And then after we do that, we'll rescan the specimens and do CAD comparisons to check for the wear that we see and see if certain textures are able to mitigate the wear that we see. And then also test the adhesion properties of these varied textures and see if any of them are able to shed the dust a little bit better than the others. Next slide. So here you can see just some basic sample textures that we've come up with. The one at the top is a lattice subtracted from the top surface of the specimen coupon.
Shawn, you have 1 minute remaining.
We'll use initially just an SLA printer with basic resin, and then move forward from there. Next slide, please. This is just kind of a brief mock-up of our test sample and the kind of images you see of those CAD comparisons. Next slide. And just some of the knowledge gaps that we have currently is that we don't have very much data on the low temperature performance of most resins that we've seen. And just picking a resin that is suitable for space applications can be challenging. We don't know if we will be able to provide consistent erosion capabilities with our sandblaster setup. And we don't know if there are better mechanisms to test erosion. And that's kind of where we're reaching out, looking for people who are more familiar with this field than we are. And then also just being able to simulate the high velocities that you see on the lunar surface versus low velocity impacts with an accompanying boundary layer of air might skew the results that we get a little bit. All right. Thank you.
All right. Well, thank you, Shawn, for your time.